scared to ask. All right, party people. So find all the solutions. Now, vague directions on purpose. Sometimes they like to do the vague directions. You have to know, should your answers be in degrees or radians? Radians. Big whoop. Okay, we can do radians all day. The other thing, of course, you have to think about, do I have to add the coterminals, the 2 pi n, or do I not? Well, before we talk about it, let's get into it. First, I'm going to get tan alone. I'm going to add the 1, divide off the 3. Might help if I remember the x there. There we go. And of course, I'm going to cancel squaring with the root. So plus or minus square root of 1, 1, square root of 3 is what it is. Now you could rationalize that. You could use the unit circle. So I specifically picked tangent because sometimes I think it's a little yuck on the unit circle. So I am going to go old school with the triangles. I'm going to start here in quadrant 1. Now tangent, TOA, opposite, adjacent, for the thrill of knowledge or missing side, of course, 2. Most importantly, what is the angle across from the side that measures 1? 30. Okay, now plus or minus 1 over root 3. We're technically in how many quadrants? 4. I do not want to have to draw in 4. It's obnoxious. Next question. Do I have to add the 2 pi n? We have to address that, the coterminals, right? So I'm going to do my 30 degrees. I'm going to put it in radians, pi over 6. But I know I have to add the coterminals. But I don't want to do all 4 answers. It's 8th hour, we're tired. We want to work smarter, not harder. So if I just want to have this toggle between quadrants 1 and 3, I'm not going to add a full circle. You would add half a circle, which is just pi. So that would give you all the answers now here in quadrant 3. I'm not going to redraw. I'm just going to roll with it. Hang on one second, Elliot. Of course, we need 2 and 4. So I'm going to put my 30. I'm going to get my answer. Of course, you're 30 short of 180. So first, give it to me the easy part, degrees. If you're 30 short of 180, how many degrees? 150. What is that in radians? Got it. And again, to get my answers in quadrant 4, I'm just going to add half a circle. Are you welcome to draw all 4 and add 2 pi n to all 4 for sure? I don't care. I would totally take it. I don't have that in me today, right? Okay, Elliot, did you have a question?
No.
Okay, just wanted to make sure I didn't ignore you. All right, let's do it. Solve the following, give your answers in radians. Now, here is where, remember, it said on the title, you're going to have to use some identities, and I'm going to show you they're on the back side, the multiple angle ones. Here's why we're going to be using identities, even though it doesn't say it. 1, I don't like your indifferent trig functions. I don't like their sine and cos squared. I need them to be the same, okay? So right away I'm like, ooh yeah, cos squared. Cos squared is on my Pythagorean identities. So anytime I'm going to use an identity today, I'm going to put it in green. So what's cos squared on your Pythagorean identities? 1 minus sine squared. Got it. Okay, now little algebra here. We're going to distribute the 2, of course. So I'm going to have 2 minus 2 sine squared. I just have more algebra to do. Now it's quadratic because of the square. Anytime we solve a quadratic, which we try by factoring, who wants to, quadratic formula this? I sure don't. Anytime I'm going to factor, I'm going to set it to 0. So I'm just going to add my 2 sine squared over and subtract the 2. So I'm going to have 2 sine squared. I'm going to put it in the correct order. I'm going to put sine next. And I'm going to combine my like terms. If I subtract 2 over, 1 minus 2, got it. And we can now factor on it. So of course we just need 2 and a sine to get 1, of course, 1 and 1. And now we have to think about our positives and negatives. So to get this to FOIL back out to 2 sine squared plus sine minus 1, you tell me, plus or minus right here. What do we got?
Minus.
And this would be a, so you have 2 sine squared plus 2 sine minus 1 sine, there we go, minus 1. All right, set each factor to 0, and then we're going to pull out the unit circle and get our angles off of it. So I'm going to add 1, divide by 2, so we're going to have a half. and I'm going to have negative 1. Now, personally, I like sine. If you have sine or cos, super easy. I'm not drawing triangles. You can draw triangles, but of course I'm going to pull up my unit circle. So I'm looking for where sine is a half, sine is a half. Oh, there we go. Sine is a half, sine is a half. Got it, got it. And our other answer, we need where sine's negative 1. So negative 1 right there. So I'm just going to jot down all those corresponding angles in radians, and question of the day, do you need the 2 pi n, the coterminals? Look at the directions. We're split. Does it limit you to one circle? No, it does not limit you to 0 to 2 pi. So I do need all the coterminals. So I'm just, like I said, I'm just going to steal these right off the unit circle. I've got pi over 6, 5 pi over 6. Let me start writing here. Pi over 6 plus 2 pi n. And of course we had our 5 pi over 6, 2 pi n. And we had that 270, our 3 pi over 2, 2 pi n. Okay, so one thing, we're going to do a little calculator shenanigans here for a quick sec. We need to kind of talk about, and you can tell I haven't even been crazy about doing it. Have we checked any of our answers? How often do we actually really check our answers? I usually don't either. But always prepping you for something. We probably should talk a little bit about checking our answers because it's going to come into play here sooner or later. Now, you can do it on your calculators. So I'm pulling up my calculator. Now, I'm in degrees right now. I don't know, I just threw this on here from earlier from geometry. I'm going to roll in degrees. I think it's honestly a little easier to type it in degrees. So my first answer, and I'm ignoring the 2 pi n, I'm just looking at, I'm not going to check all 3 to bore you, but let's check 3 pi over 2. 3 pi over 2 is what in degrees? 270. I think it's easier to type 270 in than 3 pi over 2. You're welcome to put your mode in radians and do 3 pi over 2. I'm going to do 270. So I'm going to do 1 plus the sine of 270. So there would be my left side. And now I'm going to make sure that that's what I would get for the right side. So 2 cos 270. Now this is, don't get me on a Texas instrument bender. I'm going to try to keep it together here. You have to, it looks weird, put the squared afterwards. It's just how Texas Instruments rolls. Okay, both sides equal 0, 270 is a win. Okay, so that's how you could easily check your answers. Now, do I always check my answers? No, I feel pretty good about it. But you're going to see there's a case that's going to come at us where we probably should take a look and check some stuff. Prepping you. All right, I'm done with that. Let's do B. Now, right away, I don't like you have sine and cos. Muy malo. There's my good Spanish for you. Identity. Notice I wrote in green right there. That is your double angle identity. 2 sine cos. That is found under double angle identities. So a little different from yesterday. Like I said, you're going to have to do a little more with your identities. Not that that's a big deal. I mean, you get the sheet. Cos in both. Let's factor it out. So I'm going to have a 2 sine and a minus 1. As always, I'm going to set each factor to 0. I'm going to set this to 0 and solve it. We'd add 1, divide by 2. Okay, we got it. Now, don't I have the answers for sine equals a half from the previous problem? Yeah, I'm just going to copy this down in a little quick second. We do need where cos is 0. So looking at your unit circle, of course, cosine is 0 at our top and bottom point. So I'm going to add those. So we're going to have 4 total answers. 2 for cos of 0, 2 for sine a half, and they all have to have plus 2 pi n. Gosh, I hope I can sneak it all in here. Okay, so for cos of 0, of course, we had our 90 pi over 2 and our 2 pi n. We had our 370, our 3 pi over 2, and our 2 pi n. And then I'm just going to cheat and copy the pi over 6 and 5 pi over 6 from the last one. And I'm running out of room. Gotta write small. Got it. So I think, still relatively easy, just time consuming when you have to write out all 4, okay? So, now, we're welcome to check them. You could use the degrees, punch it in, check in the original. I will tell you that they all work. Riley, what did I miss right?
Can I do pi divided by 2 plus pi n?
For this one to combo it, sure, for sure, for sure. Any questions on that guy? All right, next one's my favorite. Let's do it. I feel like it's the front side that's always a little dicey, and the back side actually gets easier. Same on your homework, okay? Not that these are bad, they're just time consuming. Now, take a look at this one. Notice you got the little note there. You're solving in the interval 0 to 2 pi. So it's always the question of the day, do I have to worry about the coterminals? Nope, winning, okay. Now, next thing, I don't like you have cosine and sine. We have different functions, and what am I going to do with that? I can't put them together. So, work smarter, not harder, of course. Here we got to be smart. If those were squared, then I could go under my Pythagoreans and maybe work something out. So here's kind of the gross yet fun part of it. We have to square both sides, which means we have to do a full FOIL over on the left. That's fun. Okay, so I'm going to start FOILing. We have cos squared. Okay, combine your middle terms. What do you have in the middle? 2 cos. And then, of course, plus 1. Okay, now the question is, I'm picking up green because we got the squareds for my identities. Are we going to replace the cosine squared or the sine squared? I do the sine squared. We have more cosines. Let's get this guy out of here. So under your Pythagorean, sine squared, of course, 1 minus cos. So identity, remember we're going to always write identities in green today. Why not? Now quadratic, the squared, I'm going to set it to 0, and I'm going to pray it factors, of course, right? So let's add our cosine squared over. So that will put you at 2 cos squared. 2 cos in the middle. Hey, nice. The 1's cancel. Okay, all right. That's not so bad. Let's factor. I'm going to pull a cos out. So I'm going to need a 2 cos. Oh, a 2. I should take a 2, right? A 2 out, 2. Yeah. What am I doing? Let's do a 2. I'm going to have a cos and a plus 1. Okay. So set 2 cos to 0, or really, I would just divide the 2 off. That seems obnoxious to write. I'm going to divide the 2 off. So cos equals 0. Cos equals negative 1. I hear you guys getting out your unit circles. I love it. Get out your unit circles. Hit me with your 3. Get ready for this. Potential answers. Hit me with your 3 potential answers. What do you got? Pi over 2. What else? And pi. So, first question. Everybody agree with the 3 Avery gave us? She is correct. But anybody need some? Get this? Okay. Now. Let me put my calculator. Let me erase this. Okay. Notice I said, here it comes into play. I'm going to get into the y in a second. 3 potential answers. So I know, I myself, I'll be honest, I don't always check my answers. I'm going to on this one, and I'm going to talk about the y in a sec. So first I'm going to check the 90. So I still have my mode in degrees. I'm just going to work with degrees, so 90. So I'm going to do cos of 90. I'm doing the left side, plus 1. Okay, cool. And then, of course, sine of 90. I don't even know I'm typing that in. We just know it. So check-a-rooski. Now I'm going to check 3 pi over 2. I'm going to use 270 degrees, of course. So cos of 270 plus 1. Okay, so 1 sine of 270. I'm nervous. Crud. Does 270 check? No. All right, you check pi. Check pi. I'm going to talk about it. Just check pi for me. How's pi working? Pi a win? I like pi. Okay, so first off, 3 pi over 2 in the math world is what we call an extraneous solution. Oh gosh. It's an answer that when you check it, it does not work. Now, pro tip, of course, because you've seen me. Have I checked every answer today? Do I check every answer?
No.
Why I'm like, oh gosh, I should check this one. What was the, and I erased it. What was the first thing we did? Squared it. So I really kind of manipulated the equation more so if you just divide by 2 or, you know, multiply everything by a half or something. I really manipulated it by squaring it. So the squaring is why I was like, oh man, this one's making me nervous. I probably should check it. So if I do anything crazy where I end up with like a variable in the denominator, not going to happen today, or you really manipulate something by squaring it, that's where I start to sweat a little bit and think about checking my answers. So I checked it because of the squaring in the very beginning. So if you're doing a big manipulation to your equation, something more so than you divided everything by 5, okay, that's where I'm going to worry about checking. How often does it happen? Rare. It's super rare. But, you know, something we should address, okay? All right. Moving on. Solve the multiple angle. I like these. These are nice. All right. First question. Are your answers in degrees or radians? Radians. Do you have to worry about the coterminals?
Yeah.
Yep. Okay. Now, what is this whole multi-angle shenanigans about? They're referencing this. So that, of course, is really 1/2, if you think of it coefficient style, 1/2 x. Now, yes, we have identities for that. I don't have to use that crazy looking square root identity on your sheet. Just sit tight. We're not going to do anything with that. I'm going to deal with the 1/2 at the end. Okay? So for right now, look at your unit circle and tell me when sign is 0. Unit circle, when is sign 0? Where does sign equal 0? Pi and 0. The left and right points, pi and 0. So, now, of course, I'm going to add the coterminals. Notice I haven't done the left on purpose. And here's where it gets fancy. Instead of me just writing x equals, we have x over 2. Okay, what else? So all I have to do now is the extra algebraic step to get rid of the over 2. How do you get rid of over 2? Multiply by 2. Everything. I mean, I don't know if I'd worry about the 0. So all the multiple angle identities are is you're going to have to do a little extra step to get x alone. So my 2's are gone. 2 times 0. I'm not writing 0. 2 times 2 pi n. 2's are gone. 2 times pi. 2 times 2 pi n. Okay. So the multi-angle, you have to do a little extra work. Now, question. Doesn't it kind of seem repetitive and similar and etc.? I totally would take those answers. Is there a way you could combo it and boil it down? Of course, right? Why would I ask if there wasn't? I'm kind of, not very sneaky. What do you got, Elliot?
I believe just 4 pi n includes 2 pi.
So 4 pi n, would that include 2 pi? Because if I put a 1 in there, 2 in there, so on and so forth. What about go smaller?
Well, can n only be an integer?
Yes.
Oh, I see.
What about go smaller? Because think about this, and I don't care, like I said, how you roll with it. 2 pi n, of course, is your full circle. Well, 4 pi is going to take you around. 2 pi plus 2 circles still keeps landing at the same spot. Do I care if you condense it down? No, I don't care, whatever. But you're welcome to do the 2. Or if you're like, oh, I just keep landing here at 2 pi, even if I do 2 circles around, I still land there, okay? You get the same thing. All right, don't worry about the 2x. Don't worry about the 2x. Figure out, I think you could maybe unit circle this one. Figure out first for me where tangent equals 1. At what 2 angles in radians? Start with that. So in radians. So think about, it's gotta be 45, 1 over 1. So what's 45 in radians? Start with that one. Pi over, and my coterminals. And then I hear 5 pi over 4. And again, like when tan is 1, that's easy to do off your unit circle because I look for root 2 over 2, root 2 over 2. They divide out to 1, of course. Now, new fancy exciting step here, sarcasm. Of course, we don't just have x equals, you have 2x. Like what? How are you going to get rid of the 2? We have to divide everything by 2. Well, it's really not all that exciting. Getting carried away here with my over 2s, but you get it. Okay, so my first round of answers, we got to do a little fraction work. What's 1/4 divided by 2? 1/8, so I'm going to put pi over 8. And then the 2's cancel. Same thing, 2's cancel. 5/4 divided by 2, 5/8. And then 2's out, pi out. That will adjust it. Got it. Any questions on that? Man, I'm a little sad it's our last problem of the chapter, everybody. Okay, cosecant. X over 4 equals root 2. Now, unit circle, of course, has our sine and cos. That's what we like to work in. And we can make tan out of it, obviously. I don't love cosecant. So, I'm going to flip it, reciprocal it. I don't know if reciprocal can be used as a verb, but I just did it. And of course, that's going to make this sine. Now, here's where people get crazy on me. They want to flip the x over 4, and I'm like, what are you doing? That's just the angle measurement. You leave that alone. You do the reciprocal to the sides. Or, of course, we recognize that rationalized root 2 over 2, obviously. So, let's just go with our x over 4. Get it done. What two angles have a sine of root 2 over 2? Give me those first. Sine root 2 over 2. Find it on the circle. Pi over 4. What else? We got it. Okay. And don't forget our coterminal friends. And of course, your little extra mental math step to get rid of the over 4. You're just going to times everything by 4, which do it in your head, obviously. So I'm going to have x equals pi plus 8 pi n. That's fun. And then I'm going to have x equals 3 pi plus 8 pi n. Got it. Any questions on that? Okay, the last thing I have for you. No, just come on. Relax a minute, people. Besides the unit circle here. Okay, so last thing I have for you, and this is no big deal, but just on your homework, number 2 and number 3.
You don't have to do them.
You're doing crushing my soul. Okay, so those, remember, we did some from yesterday, the very last example we did yesterday, where you do not get perfect, nice numbers off the unit circle. Like you might have, I don't know, sine equals 3 over 7. You are going to have to calculator it and give the decimal approximation. Make sure your mode is in radians for those, okay? So I'm just, because I've been working in degrees on my calculator. So just a little tip-a-rooski, and you're going to get decimals. Those are the only two. The only two.